Let me record this session. Okay. See, what I would like to do actually for this particular session, I'm just introducing that, Kaggle website. Okay. So this Kaggle is it's a very famous for who really working with data science, or who really looking for jobs on AI, or who really looking for some kind of project kind of stuff. Kaggle is the best source for us. Okay. So have you heard about Kaggle ever, Christina?
Yes, Anton. I've worked few projects from Kaggle only.
Okay. So what kind of projects you work from Kaggle?
Like I worked with deep learning project. I worked on a deep learning project then, uh, and machine learning project also, like Instacart project. Yeah, I worked
Okay.
from Kaggle. It's only yeah.
Kaggle itself. Kaggle is providing data sets, right? So, we don't worry about, 10 years back, the problem is that a lack of data. So we can't able to create the best models. Okay. So this time data is, so because of that, 10 years back, the cost of the data is very high, which is not available in a internet, right? Okay. So, but day by day, the data is increased a lot, and data is cheap now. Okay, and so model implementation is now you can concentrate how best model you can able to create it. Okay, so this is one of a student performance project actually. So we can able to go with find the or student performance. Okay. So here the data sets are available in my input folder. So I have two data sets are there. One is for student depression related data set, and the second one is student performance data sets. There are two data sets are there in my local folder. I mean my input folder in node in Kaggle. Okay. So this is the path for that. So our aim is that we need to go for predicting the student performance based on his activities and all. So first we need to run. So this is how we can. This is the path of data sets. Okay, so which is available in Kaggle. Uh, uh, Kaggle network itself, right? So that this is the path for this particular data set. Okay, and so next one is we need to read this particular data. So how the data will be depreciated, and how the data it is available. So here, this is our data, like hourly studied. So this is one student details, how many hours he studied and what is his previous score, and extracurricular activities is there or not, what is the sleep time, okay, and sample question papers he practiced, and performance index. Like this is the performance index you want to go for predict. Okay, these are all inputs. Hours studied, previous score, and extracurricular activities, sleepovers, sample questions. Papers practiced, and if it is practiced, then how many. So this is the data inputs where we have to be considered, and our aim is that we need to go for predicting the performance index. Clear? So with help of this particular code, then we can able to display the first 10 records. You already know that with help of the read CSV, we can able to read the file where your location is available. You just give the path of that particular file, then automatically it will be reading that, the path along with the file name. Then it will be read, and it will be holding into one of variable. You can give any name. So here I just given a like, df our name. So next one is we are just displaying that how many records we have it. Here we have approximately 10,000 observations are there, with six columns are there. So these are the six columns: hourly studied, previous score. These are the six columns we have it. Am I right or not? There are six columns or more than six? It's a six columns. The next one is here we have a describe method is there. With the help of the describe method, we can see only statistical. numerical columns what we have it, those statistical information we can able to retrieve it at a time. So mean of this numerical column element and previous score is also, it's a kind of numerical data, so that we are getting the mean value and sleep hours and sample questions, preparation and performance index. So these are the numerical elements. Out of six, of there are five are numerical elements, one is only categorical kind of stuff. So with help of the df info, then we can see that what are the data type each and every feature, and is there any null values are there. So that also we can see over here. Okay. And so we can check, is there any duplicates or is there any null values are there in your data sets. If you have any duplicates or null values, if you have a duplicate, there is no it won't much impact on your model performance, because same data it was training multiple times, that how we can get somewhat out out overfitting kind of stuff you might be getting. So that's the reason, if you have any kind of duplicates are there, then you have to be remove those particular duplicate elements. So I'm just finding that is there any duplicates are there with help of a duplicated method. Data frame dot duplicated, then it will be showing you how many duplicate observations are there. There are 127 duplicate observations are there. Okay, so simply we can able to remove those duplicates with help of drop duplicates. Okay, so after you duplicate removal, then there is no duplicates in your data. After, and next one is, if you have any kind of
So,
categorical
okay, we started the data, currently data, the first week.
hello, hello.
We can hear you, Anjan.
Okay, yeah, I'm getting some other
Yeah, there is some disturbance. Okay. Yeah.
yeah. I'm just waiting where who that. Okay, fine, no problem. I'm just showing you, like, how data is distributed and all. For that one, we already learned some kind of statistical kind of stuff that we can apply over here. Okay, and um yeah, first we seen that some kind of numerical kind of stuff, and if you have any kind of duplicates, and we need to remove it. The reason why we are removing the duplicates, and it is there is no meaning to have the same data multiple times, and because of that one, there might be a chance of getting the overfitting. Overfitting means for training area, it will give the good results only, but while if we give some unknown data, that moment you will get some kind of bad results. So that kind of thing we can say that low bias but high variance. High variance in the sense there are, in terms of testing data or unknown data, that we can call it as the variance. And bias means there are in terms of training data, that we can call it as the bias. So bias will be the less only, but variance, it could be a chance of high when we are training with the duplicate elements. So that's the reason we should definitely drop duplicate observation from your data set. And these are the two these are the label encoder. These are the pre-processing libraries, label encoder and standard scalar. Label encoder, it could help you if you have any categorical data like yes or no, or some kind of category kind of data if you have it. So those data you need to be converting into the numerical format. For that, we can use the label encoder class. Clear? So, because machine learning models can understand only numbers, not any characters kind of stuff. Okay, that is the reason categorical data need to be converting into the numerical data. For that, we can use the label encoder or one hat encoder. Different methodologies are there. Out of that one, label encoder, it is a good practice. Okay. So that is the use of the label encoder. We are created the label encoder object, and so we are just provided that your categorical data as input to this particular label encoder. To the fit transform is a method inside of the label encoder. So automatically this particular data, categorical data, it was converting into the numerical format when you were given input to this particular method. Okay. So that's how your categorical data could be converting into the numerical format. So if you want to see that, how a df will be looks like, then df dot head, just give it, and then it will give you all our numerical formats. See, previously this extracurricular activities, there we have s and no is there. Now it was converted into 0 and 1. Clear? Here we have only two elements, or two observations are repeated in extracurricular activities, yes or no. But if you have more than two or three observations, then automatically the numbers are 0, 1, 2, 3, something like that. Okay. I hope if you see this particular data, everything it could be, numerical format only. So whenever your data set which is in a numerical format, then only we can do some kind of model building, or else, if you want to find the relationship between, if you want to apply the correlation on numerical elements, then we just give you correlation method. With the help of correlation method, we can see that, how the two variables are correlated or related to each other, how strongly correlated. Okay, that we can see with the help of the correlation matrix. And this is your figure size, and so we are giving this particular matrix to your heat map, and then you just see that this particular graph, and one indicating that strongly correlated, and zero indicating that no correlation, minus one indicating that strongly negatively correlated. See, previous score and performance of this one, it was increased. I mean, both are positively correlated. See, previous score, it is like 0.92, and your performance index, corresponding performance index, it was 0.92, right? Which means previous score and the performance index both are correlated strongly. And rest of things, there is no much correlation. So the some of things, it could be negatively correlated, each and every one. See, this hourly studied and previous score, um, no relation. Hourly studied, see, hourly studied and performance index, there is some positive relation, right? It's a 0.38, and so here the performance index, it was bit good, right? So hourly studied and the previous score giving some kind of positive kind of meaning for that. Okay, and see. See here, whatever the columns which are not much correlated, then you can simply remove it. See here, 0.03, 0.05, 0.05. That means sample questions paper practiced and cell powers and extracurricular activities. It is not making good relation, or which is not impacting our performance. Then there is no point of keep those there is no point to keep these particular columns in your data set. Am I right or not? So here, extracurricular activities, sleepovers, and sample question practice papers are not giving much impact on your performance index. Is it correct or not? The data is still saying, I am not saying anything. So 0.38, it's a good positive sign. 0.9892, it's a positive sign. But rest of three, so which are not giving any impact on your performance. So that is the reason we just simply remove those things. Once if we remove, then we have only uh, three columns right now. What are those? What are those? Only hourly studied, previous score, and performance index. Now, see, here we just try to observe here. Hourly studied is a 1 unit, and the previous score is a 10 units, and performance index is like, it's also 100, 10 units only. So units means like here only 1 point, one number, but here we have two digits, and here we have three digits, two digits are there. See, standard scalar, we have to do normalization. So when we do the normalization, then your model will give you good performance. That is the reason standard scalar is a method. It was converting your entire data into the same scale. So here the scale is different, right? It's units once, it's a 10 units. So its units are not in the same square. So that is the reason if you apply the standard squarer, the whole data we can convert between -3 to +3 with help of the standard squarer. Okay. So your entire data you're converting into the um, your x your you just remove that rest except performance, everything it could be your x data, rest of things your performance index, your y data, that is your dependent variable. So next you are transformed and you are converted numerical, you are convert or you are scale your data into the same range. After that one, you must have the training data and the test data. Training data, it could help you to train your data, and the test data, it could help you to test your model after you building. Okay, for that you must have training data and test data. So with help of the train test split, we can we can convert your data set into the two, we can split into two parts. One is for training and one is for testing. So here we are using the 0.1%. That means 90% of the data we are used for training, and rest 10% we are used for testing purpose. Okay. So if I use the random state is 42, then you can run the same code every time the data points are not changing. If you split, and it can be split same data elements, you will get same data elements even you split next time also, because with the help of the random state you will get that kind of thing. Okay, so here I have 882 and is my training data, and this is 988 is your testing data of your x, and this is for your dependent variable, and this is your dependent variable. Okay, sorry, this is no, this is your training data. Okay, this is your training data, and this is testing data of your x data, and this is your dependent variables of training, and this is your dependent variables of test data. Okay. Yeah, so now you know that linear regression I already explained. The equation, it could be very straightforward, y equal to mx plus c, if we have only one simple linear regression. If it is a multiple linear regression, you might have the equation y equal to m1 x1 plus m2 x2 plus c is your constant value. Okay. So your m1 and m2 are intercept coefficient values of corresponding your input variables. Okay. So mean square error, R square error, these are your matrices to validate your model is a good fit or not. So anyway, you must have the features are your previous score, and X train and single train, and okay, so you have training data, and you're building only simple linear regression. Simple linear, we are taking only previous score as your input variable, and you are training your model. Once you're training your model, you can able to display that your x data and y data, and how it will be. See, this is the green color bubbles are like your actual data. This is a red color line is your predicted line, and this is your previous score, and this is your performance index. And you build only simple linear regression because you are considered only one input over here. Okay, and previous score only we are considered as your x data. So this time, if your previous score increases, your performance also increases. That is the thing it was giving. See, even your R square, it was very high. It was around 83 percentage, and mean square error, it is some kind of 59. It's very high. And so now what we are doing, actually, we can train with multiple elements. Like you can consider the two inputs or more than two inputs also. Okay, so this time also your model performance increases. Okay, see, this time it's so too strong. See here, the data distribution bit of variation is there, but here all points are in the same, all are in the same straight line, all are in the same line itself, that red line itself. I know when we are increases, when you are added one more feature, then your R square was increased or not, and your mean square also has been reduced. So instead of using only one feature, so your model was good, but when you added two features, your error was reduced and your R square was increased. So this indicating that your model giving a better results when we are consider the two inputs. Okay. And you want to see that, how it was correlated. Oh, actually, I have not taken, I have deleted, right? That's the reason I'm getting this kind of error. Yeah. So, see guys, till have explained simple linear regression and multiple linear regression. Okay, that is our previous sessions have shared that some content over here, and I'm just showing you one small use case, and you can try to go with Kaggle and get any one of the linear or multiple linear regression project and try to execute it and try to observe what is happening. Okay. So that is for today's session. And tomorrow I would like to plan classification kind of stuff. Okay. So I would like to explain you classification stuff, and we'll work with one project on classification. And after I completed a regression one and classification one, then what I can do, we'll see one real use case. Real use case in the sense we are going to be creating some backend kind of code and streamlet, and there, from front end, if we are getting some kind of values and how the model will be work, and let's work together on that particular use case actually. So then it's I would like to go for creating project structure oriented code, and there we do have some kind of models and we can create, and we can use our requirement, and or else we can once model is trained, and we can save that particular model, and so in real time how we can use it, and that entire project building from the scratch, front, back end, and model building both will see. Okay.
Okay. This Kaggle, what we
Create
need to
your
do, Anjan?
Yeah, in Kaggle, we can try some other because Kaggle is the ocean for various machine learning models, and keep look for some projects, and is there any kind of linear or multiple linear regression use cases are there, and if whatever the domain you are interested, and you can search for that domain specific project, and we can try to access that code, and then we can start executing from your Kaggle area. So, and while you're executing and you are getting some kind of results, and you can try to understand why we are getting this result, what is the meaning of it. So those kind of code we can try to explore it. Okay. And while you're
Okay.
getting some kind of stuff, and there we are getting some kind of you know um, names, or else some kind of previously I have shown you some kind of skewness, quartersis kind of names in our OLSA method, right? Okay. So somehow we are getting some new names and all, and we can try to understand the meaning of it, and why we should use, and where we can use, and that kind of knowledge we can try to get, you can try to explore it while you're executing some unknown projects and all. And someone is already implemented, right? We are trying to be executing on it, right? So what is the purpose he has used, and you can try to explore in such a way.
Okay. Understood.
Yep. That's for today's concept, guys, and hope you understood. And yep. Thank you.
Yeah. Thank you, guys.
Thanks, Sanjay.